Okay, 9.2 exponential decay. So recall, what is an exponential function? Today we will focus on exponential functions that move towards asymptote as you move left to right. So remember that we read left to right, so that's how we're looking at it. So here are some examples of exponential decay. So looking from left to right, if it's high up and then starts to level out towards your asymptote, that is showing exponential decay. Also, it could be reversed and look something like this. Okay, that's also exponential decay. And depending on where your asymptote is, remember for us, we're just focusing on our asymptote being where y equals 0. But when you move into IM2, this, if you have an asymptote here, moving towards it like this or like that, would also represent exponential decay. Okay, so why don't you write down 2 examples of real world application where exponential decay functions occur. I do not give several video examples in this video. I want to hear from y'all's in class. Okay, so jot some down and then continue. Okay, so how do you know if y equals a times, remember we're using r, a times r to the x power represents exponential growth or decay function. So it's exponential growth if r is greater than 1. And it's exponential decay if r is less than 1. So just by looking at the ratio, you'll automatically know if it's growth or decay. So here are a few examples. They want us to identify the following functions as growth or decay. So on A, right here, here's r. That is greater than 1. 3 is greater than 1. Therefore, that is growth. Okay, so why don't you go ahead and try the other 5 on your own and check your answers with mine. Okay, so hopefully this is what you got for your answers. Don't let E and F confuse you. Since that's a negative exponent, you must flip the base. So it's your ratio is not 5, it's actually 1/5. And so since 1/5 is less than 1, that's actually showing decay. Same thing with F. That's a negative exponent, so you flip your base. So it's now 10/7, which is actually greater than 1. So that shows growth, okay? So you really have to think back to the previous chapter, chapter 8, when we talked about exponents, because that's going to play a big part in chapter 9. All right, so now we are going to graph exponential function that is decaying. So remember in 9.1, I actually made the table first and then I created the graph. I find it easier that way. You can do it however you want. So I'm just going to start with some values, -2, -1, 0, 1, and 2. And it just kind of helps you see also the decay as x is increasing. So remember, all you have to do is plug these values in for x. So I'm just going to zoom in really close. So it's 3 times 3/4 to the x power. If I use -2, it's now 3 times 3/4 to the -2 power. Negative exponent, we flip. So now it's 3 times 4/3 squared. And then remember, if you're squaring a fraction, you just square the numerator and then square the denominator. So 4 squared is 16, 3 squared is 9. Okay, and so now it's 3 times 16 over 9. Now don't freak out. It's okay that you have a fraction here. Remember, you can cross simplify before multiplying. So the 3 and the 9 kind of dwindle down. And then 16 divided by 3 is about 5.3 repeating. Okay. At least I think that is. If I'm wrong, just let me know in class. Okay. Same thing with -1 now. 3 times 3/4 the -1 power. We do the reciprocal, so now it's 3 times 4/3 to the first power. Then you just multiply, cross simplify, so we get 4. So when x is -1, y is 4. Remember that when x is 0, it's just your y-intercept, which is the a value. So this one's 3. And then just finish these out real quick. First power, so this would equal 9/4, which is actually 2.5. And then if we have 3/1 times 3/4 squared, we have 9/16, which is now 27/16, which is just below 1. I don't know the exact decimal point, but I'll just write it like that. Okay, so we actually have 3 really good points here. So you can graph at -1, 4. Whoops, I guess it would help if I actually had the pin selected. Okay, 0, 3, and then 1, 2.5. Okay, so as you can see, it's starting to curve and move down towards the asymptote. Okay, and then you can also notice here on your table how the bigger x is getting, the smaller those y values are getting. Okay, so the domain for your exponential function is still all real values, because it's going to be any x value. You put any x value in there, your y value is just going to keep getting smaller, and in this case y is anything greater than 0. Okay, all right, let's go to the next page. I think we're actually done. Let me look. Okay, sorry about that. All right, so then remember, for exponential growth, it was 2 given points would always be 0a, 1a times b. And then for exponential decay, it'll be -1, and then it would also be a times the reciprocal of the base. Okay, so those are 2 given points for you there. All right, so let's do, no, we're good, because we don't really need to talk about the bottom. You'll learn that next year. So we'll just kind of cross that out. All right, if you have any questions or comments, just leave them at the end of the video. Sorry if it was a little messy, but I'll answer any of the questions you have in class.